Good morning, folks. This is the first of the short 5-minute videos on isolated topics that are outside the main VILT 5-day lectures that are part of this course here, this Integrated Petrophysics for Reservoir Characterization, IPRC. So hopefully it'll be a short little 5-minute video. I've had to select isolated topics that are outside the main VILT in order to supplement and try and get across to you all the main things that are in the course. Probably won't obviously not as good as attending the 5-day course when you really get the full bang, but this is just something that I can do to help get information across. Right, the subject of this is going to be data hierarchy. It's at the beginning of the course. It's part of the basic concepts, and it's quite an important basic concept. It's basically about the fact that when we do an integrated petrophysical evaluation today, we have an array of different data to solve a given problem. If we're solving, let's keep it simple, we're going to solve porosity, right? We don't only have one logging tool even to solve for porosity. We have at least 3, maybe 4. We have density neutron, sonic, and maybe NMR, for example. And all the other, many other logging tools, of course, as well are related to porosity. So we have a choice of the way that we're going to evaluate it. Now, how do we make the choice about how to evaluate it? Well, my contention is that we should at least choose the data or the arrangement of data which most closely relates to the true value. So, and we put it into a hierarchy. For example, we'll put a density tool, a well-calibrated, properly run density tool, we will put fairly high up the data hierarchy list, whereas an old-fashioned GNT neutron tool, which has also got a relationship to porosity, but a much softer and more problematic relationship, we'll put it below below density in the data hierarchy. That's what I mean by data hierarchy. Think about the objective. We're trying to determine porosity. Think about the array of data that you have that relates to that parameter, and then rank it. Put it in a hierarchy, and favor the data which is highest up in that hierarchy. Now, how do we put it into that hierarchy? That's what I'm trying to suggest to you how we actually do it. Obviously, if you've been working with reservoirs for a few years, which most of you have, you will be doing this in the back of your mind, probably without thinking how you're actually doing it. My suggestion to you is that we are actually intuitively using the directness of the measurement to the real absolute value of that parameter, the accuracy of the measurement, has it been measured accurately, or has it been measured with a miscalibrated tool, for example, and thirdly, the spatial definition. Do we know exactly what bit of rock was measured when we made that measurement? And how does that bit of rock, is that bit of rock the same bit of rock that we're going to use with another measurement that was the same bit of rock that gave rise to another measurement that we're going to use in an equation in the petrophysical evaluation, like, for example, resistivity? Has the resistivity been derived from a bit of rock that's this size, and the porosity been derived from a bit of rock that's this size, much smaller? And we need to be aware of this spatial definition issue when we're putting these measurements together in one equation, because of course one equation will always assume that the measurements have come from the same bit of rock, something which we never actually, say or think, but actually that is, of course, an assumption of almost all petrophysical evaluation. I'm going to pause and show you a slide. Now, here is a slide which is laying out these 3 parameters: directness, accuracy, and spatial definition. And it is also talking a little bit about them. But in my idea here is that directness is the most important of the 3, usually the most important of the 3, and an example of a measurement that we commonly use, which is not very directly related to the reason why we acquire it, which is we acquire resistivity to measure saturation. Actually, we're not measuring saturation, we're measuring resistivity or conductivity, and we have to relate it to this thing through all of these other parameters in an equation or equations, which in order to do that, of course, we have to know the equations, and we have to know the values of all of these individual inputs to that equation. So this measurement is quite indirectly related to this thing that we're measuring it for. And that is why I believe it's not actually a very good way of determining saturation, even though it's the most common way. Okay, so that's it, folks. Just remember that when you do your evaluation, you are, whether you realize it or not, you are doing some sort of data hierarchy. If you're just pressing buttons in the software, then of course the software is written to assume a certain hierarchy. And that's one of the reasons why we need to not just press buttons in software. We need to always think about what's happening. Okay, that's over.